Hello and welcome to ML with AP. The topic for today is Matplotlib. We are going to learn top 15 commands which will get 80% of your work done. Let's start. But before that, why Matplotlib? We all know that it's a great visualization tool available for Python. But what's so great about it? Three top reasons. Versatility. It's the oldest Python package for visualization. It has all possible features. Compatibility. Since it's very old, it is compatible with all major packages and data types. It has inbuilt support for Jupyter Notebook also. Customizability. You name it and you will have it. You want to draw line, scatter, bar, histogram, you want to do animation, 2D, 3D, everything can be done through Matplotlib. Do we have any alternatives to Matplotlib? Yes, we do have, but I highly recommend to start your journey in Python visualization through Matplotlib. The next three alternatives are Seaborn. It's a great visualization package. It is built on top of Matplotlib and hence it is very easy to learn if you know Matplotlib. Plotly, great for interactive visualization. It will give you a slider to tweak your parameters X and Y values and you can have interactive graphs. Bokeh, again, used mainly for interactions and it has great inbuilt integration with our websites also. So if you want to render your interactive graphs on website, Bokeh is the place to go. Okay, with that being said, let's jump onto our Jupyter Notebook and see those top 15 commands. Here is our Jupyter Notebook. The first thing first, we have to import our Matplotlib libraries. Okay, so traditionally we import it as plt. So import matplotlib.pyplot. Pyplot is the main interface which we are going to see today, and it is imported as plt. That's the convention. We imported it. Second thing is the magic command for Jupyter. If you're running it on Jupyter, it's very important to properly render the graphs in the Jupyter Notebook itself. So the magic command for that is %matplotlib space inline. Once you run that, all your graphs will be in Jupyter Notebook and displayed properly. First, we have to start plotting. So let's start plotting a simple plot using our pyplot interface. I'm importing NumPy to create my arrays. Okay, I'm creating my X and Y values. So I've created X and Y value. I passed a list and created two one-dimensional NumPy array. What I'm doing over here is I'm trying to plot. The plotting is very straightforward. I pass my X array, my Y array, and I passed one variable or one parameter. There are many parameters which plot interface takes or pyplot interface takes. We'll learn more about that a little later, but let's say we want a line over here as a plot. When we run this, we will get a line plot over here like this. Okay, if you want to change that with, let's say, asterisk, we'll get the asterisk value instead of the line over here. Okay, now suppose somebody wants to plot you want to plot two plots in the same. I will have a y1 variable also over here, and let me plot in the same plot y1 also. When I run this, automatically we'll see on the same plot two lines over here representing my two plots. Simple. Now, many a times we would have the need to not screenshot it, but save it programmatically into our folder. Now, to save it, it's very simple. We have created an object over there, plot.figure. We have to just save it. So figure.savefigure, my figure, or we have to provide the name that what we want to save that figure object as. When we run, now we can call it. If you have to see that, okay, this thing has really saved it, with exclamation over here, we can run our shell commands also in Jupyter Notebook. Now we'll do an ls and try to see that if this is really present over there or not. Okay, we'll see that, okay, this is present over here in my folder or the local directory. To display from the disk, again, what I need to call is the import package image, and I'm calling image over here. When I call image, I have to supply the name of the file, of the PNG file or the JPEG file which has been saved. When I call, what is rendering? It is rendering the same old file over here which I saved. Okay, so saving and rendering it back is very, very easy. Now as I was saying that there are many options, let's play with some options. So we have X and Y already, like we have two one-dimensional array of NumPy already over there. Let's try to play around with it. Okay, so the first option is line style. I have provided as dash, so we are getting a dash line style. Second option is color. You can present every color, so I'm presenting green over here. The markers, so how the points will be marked, I have marked it as O, like so it will be a small circle over here. Marker size, what will be the size of these? I'm providing a size of 12. What should be the line width? Line width is 2. So let's try to tweak it. Let's change the color to black and it will give a black color. Let's change the marker size to maybe 20. It will have a bigger dots over here. Let's change the line width to 20. It will have much thicker line over here. Okay, it looks ugly. Let's keep it back. Okay, marker size as 2 as well. 2 is very small. Let's put it as 12. Okay, and the line style as dashed, and you can get various options. If you want to see the various options, you can do two things. One is you in the Jupyter notebook, you can do a shift tab over here and it will give you the help for that, right? And you can see it over here that what are the things which are available. Okay, that's one of the way in which you can do that. The second way, and if you want to know more, you can always go to matplotlib.org, and here we have tons of resources available, so you can see the examples, let's say. And if you are stuck in, if you want to draw a particular type of visualization, let's say box plot, you can always go and see that, okay, how the box plot is drawn. It's very easy. All the tutorials and your examples data sets with visualization is present on matplotlib.org. So that's another resource which I would recommend highly to take a look if you want to draw any visualization. Okay, coming back. Now, one thing which we have drawn it, we have seen all the options. What next? The next is, okay, what are if we have to limit our accesses, right? We want to limit our figure, or X and Y variables are very, very large. And if we want to plot only a subset of that, how we can plot that? We can limit our X and Y coordinates with xlim and ylim. Okay, here I'm limiting between -1 and 10 and -1.5 and 1.5. If I'm doing it, you can see that over here my y-axis is limited between -1.5 to 1.5 and my x-axis is limited between -1 to 1. You know why this graph is coming like this and it is not extending? What was our x and y values? Okay, let me just quickly see what was my x. My x was between 1 to 8. What was my y? My y was between 3 to 10. Okay, so my y is between 3 and 10. It will not go beyond that. And my x is between 1 to 8. So 1 to 8. It is only giving you this particular shape. Okay. Okay, labeling plots. Now we have drawn the plots. We have actually squished or limited our axes also. What next? For a plot, we have to probably name it, label it, legend it. Okay. The way to do that is very simple in Matplotlib. With plot interface, you call the title method and you provide the name of the method. So a simple graph it will, and let me run it and show you. A simple graph is the title. If you want to label your multiple lines over here, the way you to label it, that when you are calling the plot method and you are calling your x and y values and the type of line which you want, on top of that you can also call label. So this first is the xy, the second is one x and y1 graph. You can, this is like, you can render any text over here, like second graph or first graph. Okay, first graph, and it will run. And you have to, now after that you have to call plot.legend and it will render you. So my first graph is this, my second graph is this, and it will show you. And simple graph is the title of the plot. Now many a times you'll see that you have to draw a pie chart, a scatter plots, histogram, bar charts. Now let's see that how those things are drawn. To draw, again, you have to call the PLT interface, and it's very simple, plt.scatter. You again provide your x and y values and the marker. Over here also, similar to how we are doing with the line chart, you have various options which you can see. Okay, I'm just putting it as a dot over here, so my scatter plot is ready over here. Okay, Now, if you want to draw histograms with binning, you can, let me generate a data for histogram. This data will not look very great in histogram. So what I'm doing is I'm generating the random number bit of 1000, the quantity 1000, and these are normal random numbers, so it is between 0 and 1. 0 and 1 Gaussian distribution of numbers, and 1000 total, right? So let's see, if I'm doing a plot.hist over data, what I will getting, I'm getting a normal, because since I'm getting it from rand n, so it's a Gaussian distribution, normal distribution, and it is between 0 and 1. Mean 0 and standard deviation as 1, sorry. So when we call rand n, it will give you mean 0 and random deviation. So you see that there are some data points which has come from more than 3 standard deviation on the right and 3 standard deviation on the left also. Okay. Now again, over here you have various options. You can select. By default, it will just plot it the way Matplotlib wants it to plot to the default values, but you can provide. Data is my data which I want to plot, right? For the histogram. Bins, I can ask them to bin it. Okay. Bins are these towers which you are seeing, these lines. So what should be how many bins should be there? So I'm saying that, okay, make 30 bins or make 10 bins. It will just that if I make a smaller number of bins, it is going to smoothen it out. Okay. Now there are other options like his type, a step field. So it will draw it like a step field and not like this particular. Okay, edge color. So what should be the color of the edge? Edges are black over here. The color of the histogram itself is steel blue. You can change. If let's say I do a more granular thing, let's say 100, okay, 100 bins. You see, it has become more granular. If I made it little less, it will be more, or the bin size is increasing, right? The width of the bin has increased because I only have 10 bins over here, okay? If you have to draw a bar plot, what you can do is we already have the XY data and I'm providing a color of this. Again, over here also you have all the options which are available and you can draw a bar plot. If you have to draw a pie chart, for pie chart, what you need to provide back over here is the ratio. In a NumPy array, what you can provide is the percentages of the area. So pie chart is also called area chart. You have here I'm providing it that, okay, I'm providing it a NumPy array with 35, 25, 25 and 15. Some of them is 100. And I'm also providing the labels and colors. When I'm calling the plot interface and I'm calling a .py method on it, I'm providing my data over here. My labels, what are my labels? My labels are my labels. Okay, so apple will correspond to 35, bananas to 25 and things like that. What are the colors? My colors, so black, pink, yellow and red. And each is mapped, right? 35 apple and black is mapped, 25 bananas and pink is mapped, and so and henceforth. Okay, so when I plot this, it will give you a nice. Now over here also in pie chart, there are various other options available. If you want to drill down on let's say on cherries, then you will have this exploded option where cherries will just come little bit outside. So it will tell you a great visualization story, right? If you want to do something like that. Now, suppose sometime there will be need that, okay, with your bar chart, you want to convert your scatter plot also on top of it. Now you have to combine those. It's very simple, right? You draw your scatter, you draw your bar, and you just render it, and it will give you. Again, over here, if you see, we have various options available, right? Subplotting. Suppose, what if there is a need that in one plot, we should have multiple plots, okay? Till now, what we have seen is that in one plot, we have multiple lines, right? Scatter and bar plotting. But what if we need multiple plots or multiple subplots itself? There are two ways essentially to do that. Okay. Now, little bit of history over here. The Matplotlib has two essentially interfaces. What we are seeing till now is plot, and I'm deliberately stepping away from another interface, which is figure and axes. Okay, those are more object oriented concepts and the way to draw figure. Both of them are being used. The plot which is being used over here, which we are dealing in this tutorial, is essentially it is a matplot. When Matplotlib was done, at that time they wanted an interface like MATLAB. Now MATLAB was a proprietary software and Matplotlib or Python was the coming up thing which was great for open source. Now when they wanted to mimic the MATLAB style plotting, they used this plot mechanism. Okay, later down the line they had this axes and figures also, so you can do this subplotting in two different ways. Here I'm only going to talk about the plot because we are only dealing mostly on pyplot interface, right? So with pyplot interface, if you have to draw, then what you need to do is you need to provide a subplot dimension. So subplot, okay, I want a 2x2 grid, okay, and this is my first plot. So 2x2 grid, 2x2 grid, and this is my first plot. What is my first plot? Plot.plt.plot xy. The second plot, I have again 2x2 grid. In the same grid, this is my second plot. Over here, this is my third plot, and I'm again drawing. I'm essentially like doing the squaring of this and multiplication so that we have different shapes of the graph, right? And I'm trying to do a plot.show. At the end, plot.show, it will show me these three graphs. Now friends, remember this whole thing can be done in a more object-oriented way using plots and figures and axes. That probably I will deal it in a subsequent video. Now there are some quick styles. So if you're drawing a plot, you do not need to set everything by the Matplotlib gives you a style sheet kind of thing where by default some of the styles can be rendered no matter what type of graph you are drawing. Okay, so all the type of available styles with Matplotlib is available over here, okay, in a list called available. And let me render it the top 5 one, or let me render it the top everything. Okay, so these are the type of things which are available. Now if you can see that dark background 538 ggplot type, you can use any of their styles and all the graphs rendered afterwards will be in that particular style. So if I'm using a dark background and I'm doing it on the data, which earlier I have already done over here, if you recall, yeah, over here I have already done. If I do the same thing on the dark background theme, my graph will look like this. So you can try various and you can see that what is looking more visually appealing. Okay, Seaborn. Now Seaborn, we know that it's another package, it's Borner, but we have a Seaborn style. So all the Seaborn type data plotting can be done inside Matplotlib, and it will look like this. Again, I have already shown that we have these available themes or styles which are already available, and you can make use of it. One of the last thing is the 3D. Till now what we are doing is the 2D plotting. One of the last thing is the 3D plotting. How do we do the 3D plottings? For that, you have to move away from your pyplot interface and go to mplot 3D interface, right? And if you do that, what I'm doing over here, I'm trying to generate now for 3D you need X, Y, and Z, 3 coordinates, right? Or 3 axes. Then only it will, till now we are doing with X and Y. So to generate the data, what I'm doing is I'm defining a small function over here. Okay, this function is not important for visualization. Just think that I have generated X and Y and Z data. Okay, so my X is, again, I'm calling a numpy linspace. So what it is doing is between 0 to 5, it is giving me 50 data points. Okay, between 0 to 5, it is giving me another 40 data points. And what I'm going to pass it, I'm passing it through a function and generating my Z coordinates. Okay, that's all we are doing. Now, to draw that over here, as I was seeing, now you have to move out of your pyplot interface. And this is where, if you see, these type of interfaces like with axes and figure, which I was talking about, that is being used in mplot 3D, right? Okay, so this is the way in which you do your plot.axis and then plot surface to draw a 3D visualization. I've already answered that why we are not using plot or plt.plot here, because we are using another interface, not the MATLAB type interface, which is pyplot. And again, these are the two different ways in which we can do. Probably I will deal with the axes and figures in a subsequent video. Okay, so once you run this, you can see this. Sometimes what we have to do is you have to draw a contour, which is essentially a 3D projection of a 3D figure in 2D, right? If you know a bit of geography, they use it for the showing the contours of the hilly regions and the valleys and the lakes, everything, right? So all these are showing the various depth. If you are looking at from the top view, what the contour looks like. These circular lines or the concentric lines represents the various depths. If you want to draw the contour for that in color black, again, various options are available over here. If you want to run the contour, you can run the contour also. Sometimes this is also gives you a great visualizations, right? With that being said, I think we have come to the end of this tutorial and we have covered the 15 top Matplotlib commands. I'm sure that with these 15 commands, you will be able to accomplish most of your work, if not others, if not 100%. Then if you want to learn further, I would recommend again to you to go to matplotlib.org and see the tutorials over here. With that being said, I will close this tutorial here, but I do have a favor to ask you. If you like these type of content, I'll request you to subscribe to my channel, and this will mean a lot to me, and share it and like it so that I'll motivate it to create more such content. With that being said, thank you.